So we're surrounded by AI, right? And it's making these huge life-altering decisions. But what happens when we have no idea why it's making them? That's the black box dilemma. And today, we are going to pry that box open.
Okay, so let me ask you something. A doctor looks at 100 x-rays, an AI looks at 10,000. Which one are you going to trust with your life? I mean, really think about it. On one hand, you've got a human doctor, years of experience, that human touch. But on the other, you have a machine that's seen more cases than any single person ever could. This isn't just some sci-fi question anymore. It's a choice we're actually starting to face. And believe me, the answer is way more complicated than it seems.
All right, so to even get our heads around why we'd trust an AI with something so important, we have to look at the problem it's trying to solve. And that starts with the very real limits of the human eye, especially when it comes to the immense challenge of medical imaging. Look, radiologists are incredible at what they do. I mean, they're brilliant, but they're also human, you know? They're looking at massive stacks of images, always against the clock. That means fatigue sets in. And just like the rest of us, they have cognitive biases. The stakes here are just so high. A tiny shadow, something you might miss at the end of a long day, that can literally be the difference between life and death. So even these small, totally understandable errors can have huge, devastating consequences. So, given those human limits, it's no surprise we're turning to technology for help. Which brings us to the incredible promise of AI as this powerful new tool in medicine. And this is where the machine just shines. I mean, these AI systems can chew through millions of images, spotting patterns that are so subtle, they're basically invisible to the human eye. They don't get tired, they don't need a coffee break, they can do in a few minutes what might take a human expert weeks to get through. It's an absolute game changer.
But of course, there's a catch. And this is really the whole point of what we're talking about today. With so many of these powerful AIs, the how it gets from A to B, is a total mystery. We feed it an input, like an X-ray. We get an output, the diagnosis. But everything that happens in the middle, it's a complete black box. The internal workings are just so ridiculously complex that we can't really follow its logic.
Yeah, the AI expert Cynthia Rudin puts it perfectly. She says, a black box model is basically a function that's just too complicated for any human to get their head around. So we get the answer, sure, but we don't get the why. And when you're talking about medicine or the justice system, not knowing the why is a huge problem.
So this really gets down to a fundamental question, right? How does a machine think compared to how we think? Turns out there are two totally different ways of learning about the world.
Okay, this chart really breaks down the key trade-offs. Think about it. We humans, we learn with context. You show a kid a cat once, and they pretty much get the idea of cat. That's amazingly efficient. Machines, totally different. They learn statistically. They are so data hungry. They need to see millions of pictures of cats to learn the same thing. But where they completely blow us away is speed and scale. No contest.
Now, this is maybe the most important part, how they make mistakes. Human judgment is noisy. That's a great word for it. You could have two top-tier doctors look at the exact same X-ray and come away with slightly different opinions. Our judgments just vary. A machine, on the other hand, has almost zero noise. It will give you the exact same answer every single time. But, and this is a huge but, that consistency comes with a massive risk of bias. If the data you train it on has some kind of built-in prejudice, the AI won't just learn that prejudice, it'll amplify it, it'll apply it consistently, systematically, without ever questioning it.
Okay, so you're probably thinking, if the black box is the problem, why don't we just ask it to explain itself? Seems like the obvious solution, right? Well, this is where things get really interesting, because it turns out that so-called explainable AI can be incredibly deceptive.
This is a really critical point that comes from Cynthia Rudin's research. When you ask a black box to explain itself, you're not actually getting a peek inside its brain. What you're getting is the output from a totally separate second model. The second model just tries to guess what the first complex one was doing. And that second model, the explanation, can be completely unfaithful to what really happened. It can be just wrong.
Let me show you a perfect example of this. Here we've got a deep learning model, and it's looking at this picture. It correctly says, yep, that's a Siberian Husky. So far, so good. The model works.
But then, of course, we have to ask the big question. Why? What part of this picture made the algorithm think Husky? What was it actually looking at? So we ask it to explain itself.
And this is where it just gets completely absurd. The explanation it gives us is this thing called a saliency map. It's basically a heat map that's supposed to show us the pixels the AI cared about. But just look at it. The map for why it's a Husky is almost identical to the map for why it's a... A flute. No, I'm not kidding. A flute. This isn't just useless, it's actually dangerous. It makes you think you understand what's going on, but it tells you absolutely nothing about the AI's real and obviously flawed reasoning.
So if trying to get an explanation out of a black box is a dead end, what do we do? Well, the alternative is pretty compelling. Instead of building a complicated model and then trying to explain it later, what if we just built a simple, transparent one from the very beginning? Not a black box, but a glass box.
Now, one of the biggest things holding this back is this myth that just won't die. You see it all the time, often in charts that look something like this one. It's this idea that you have to choose between accuracy and simplicity. The thinking is always, well, if you want a really accurate model, it's just got to be more complicated. That's the trade-off.
But here's the thing. The data shows that's just often not true. For a lot of really high-stakes problems, the ones that use nice, structured data, think finance or certain parts of medicine, these simple, understandable models can be just as accurate as the super complex black boxes, sometimes even more accurate. We don't always have to make that trade-off. In fact, let me show you what one of these glass box models looks like in the real world.
Check this out. This is a real-deal machine learning model used to predict criminal recidivism. But look at it. It's just a simple list of if-then rules. There's no black box here at all. A judge, a lawyer, anyone, they can read this and know exactly how the decision was made. And here's the kicker. Its accuracy is right up there with the complicated secret sauce black box models that are actually being used in some courtrooms right now.
So what's the big takeaway here? Where does all this lead? Well, it points to a future that isn't really humans versus machines. It's about collaboration. It's about a real partnership. The real goal is to create something called hybrid intelligence. The idea is simple. Let the machines do what they're amazing at. Let them crunch huge amounts of data with incredible speed, without all that human noise. But, and this is key, we build systems where that power is guided by what we do best, applying context, common sense, ethical judgment. The machine is the ultimate pattern finder, but the human provides the wisdom.
And you know, this brings us right back to that first question about the doctor and the AI. It's all about trust. The biggest challenge ahead of us isn't just building more powerful AI. We're getting really good at that. The real challenge, the thing we have to get right, is building trustworthy AI. And that means we have to consciously choose transparency over a black box, especially when the stakes are so high. So the real question for all of us is, how are we going to choose to build our future?